Hi everybody. So here we are at our graph paper. This is for the 2022 paper higher level question number 2. So we're on 2022 higher level question 2, and I'm just sticking the note up that that's one of the first things to do with your graph paper, especially with question number. And you'll also have a space for your examination number as well when you're in the Leaving Cert on the big day. This is the Boyle's Law one. Hopefully you've just been watching the rest of the question, but just in case you were just coming on to look at practicing your graphs, we're going to set us up so that we can do all of that from scratch here now. Okay, you'll be given your graph paper in your exam, and for reasons I'll explain in a minute, I've decided that I'm going to go this way, landscape, if you like, this orientation, because as a rule of thumb, I like to say to give yourself to fill up about 2/3 of the page on the graph. Don't go for a tiny little graph. It makes it harder for your examiner to mark it. It makes it harder for you to. So do the best you can. This is kind of a new camera setup for me, so do let me know if you're finding something not too clear or anything like that. Now, to help us plot our points and so that I'm not going back and forth between my exam paper, my sample answer, and my graph, I've brought a little chart with our values on it. And we are going to be doing a graph of pressure versus 1 over length. So pressure versus 1 over length. This will have been explained in where the data came from is explained in the video on the Boyle's Law question. That's higher level question 2 in 2022. I'm not even going to need that first piece. That's just the data table from the question. And here I am. I'm looking to map or to graph pressure in kilopascals against 1 over L, or the inverse of the length. And I just left it in centimeters to the -1 for convenience, because it actually, for Boyle's Law, doesn't matter what your units are. You're aiming to show proportionality. You're aiming for a straight line through the origin. So whether it's in centimeters, millimeters, meters, inverse, then it doesn't really matter, because you're going to get something that's hopefully a straight line through the origin. That's what we're aiming for. I just made a copy of this and brought it here, so we're not flipping back and forth. No one is expecting you to draw your data table on your graph paper. That's going to take up time that you don't need to be wasting in your exam. You've already done it in your on your worksheet anyway, okay? I am going to plot pressure over here on the y-axis, and I'm going to plot my length down here on the x, or my 1 over length. I keep saying length, but 1 over length. And here I'm going to try and step through this, giving as much detail as I can, because graphs are classically something people find tricky. Especially, I'm thinking if you're in 5th year and you haven't had that much experience of them yet, but even if you're in 6th and they've always been just something that wasn't that clear for you, let's step through it, okay? So when you get this chart of tables, and I hope you get a chart of numbers, I hope you can see it clearly enough, and it would be in a sample answer attached to this as well if you're not so clear. But let's have a look, right? We've got pressure. We've got 360, 227, 214, 178, 154, and 136. They seem a bit of a big range, okay? But I'm looking to kind of round numbers and see if I can make something fit in my graph. And I'm seeing that I need something that goes between like 0 up to 400, okay? Just round. And so you could have like 4 or 5 boxes, but let's make them bigger, spread it out on my graph. And I'm thinking that it's going to be about 8 different boxes. And that's what's drawing me to this slide over here, okay? I'll put a pin on that for a second. It actually doesn't really matter if you decided to turn your page and just do it like A4 style. That's fine too, okay? It doesn't really matter as long as you have a nice spread out graph. So I've got something like that, and I'll come in more detail when I start plotting my points on my axis, but I'm just kind of looking at it first to get a bit of a feel for what might make sense. Now, this is something that catches people as well. So on my 1 over length, I've got 0.067, 0.050, and 0.040, 0.033, 0.029, 0.025. And you might get caught, okay, they're tiny numbers. What do I do? So look at the significant figures, and significant figures we can talk about more if people are not so sure about them. But what I'm saying is ignore the zeros at the start. So you look, now we will include them in our graph, but just for thinking about the size and the scale and the range, I kind of have a 67, 50, 40, 33, 29, 25. Okay. And I'm thinking I've got 25. So let's say I start at 0 up to 70. I could easily give those things a box each. So if this was just 67 centimeters, say, I'd probably come along here and go, 0, 10, 20, 30, 40, 50, 60, 70, and spread it out like that. Okay. So don't worry too much. Don't let those zeros throw you off. If every single point on your data table has them, just start looking at the significant figures. Just start looking at the numbers, basically the non-zero numbers. Okay. So I reckon I've like 8-ish boxes on one side, 7-ish on the other. So that's why it doesn't matter too much which way you twist it. I'm going to go with this because I'm set up this way on my camera basically, but it's not such a big deal. Let's start at the pressure. I want to have maybe 8 boxes so that I get a little bit of definition, and I'm going to put my start point. I often go here. If you can see where I am, it's a bit bright on that camera. Try not to go right down to the very start of the graph paper. Go in a bit. It gives you space to write your labels and mark things off, but also you probably don't need to be cramming everything into the little corner over here. So I'm going to call this my start point. You can see it with my pencil. It is a little bright though. That's my 0. I'm going to call it 0. And I'm going to come along with my ruler and draw some X's and Y's. I've had my axes, I mean. I've had people ask about, are pencils still okay? And I'm not sure if you know, but that a lot of the papers now are being scanned to examiners. And there was some talk that we'd have to do our graphs in pen, which would be fine, but it's a bit safer to do it in pencil. And what I understand from that is that it's okay to use pencil. That's the important part here. The scanners are really good. They're picking up and scan everything. You're not going to get anything missed, and they'll always have your original copy anyway if they have a question about it. So you should be able to see that I've got some axes here. I'm going to start labeling. I'm going to do that straight away because what I don't want is to forget my labels and lose points for something as silly as that after doing all my hard work for my graph. So over here, I've got my pressure, and I'm going to make sure to include my units. So I put in brackets kPa. Kilopascals, and over here or down here on my x-axis I'm going to have 1 over the length, and that one is in centimeters to the -1. I hope you can see my pencil okay. It's not too bad. And don't worry about seeing every single box and every single point. It's just to get the idea of what are steps I go through for making a graph. Okay, let's take our first point. That's right here in the data table. We have 360 kilopascals and 67 0.067 centimeters -1. So here's where I guess I skipped a step. Let's go back and make sure we've marked off our marks here on the label. That's going to make it a lot easier to plot our points. Okay, so over here I'm going to give myself loads of space. Every 2 big boxes I'm going to call 100. Okay, kilopascals. Should have put my line up a bit more. Kind of run out of graph paper. Not ideal, but I won't really need that bit of the graph anyway. I'm not off the page. I just have a bit much. So maybe I should start from the bottom. I've got my 0. That means every big box is 50. If you follow me. So I've got 50. I've got 100. I have 150. 200. 250. 300 kilopascals, 350, 400. And when I look at my set of data points, every one of those is inside this range. Your range is your kind of your brackets around which your axis goes. So I go from 0 to 400. That's my range. That includes everything on my data table. I'm sorted. A lot of the time, we're not going to be able to get every single tiny point. You're going to be rounding to the nearest box. Let's do our 1 over L's, our inverse lengths. I think because we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can't quite give them 2 boxes. We're going to give them 1 each for every kind of 10. And when I say 10, this is where you'll be careful to bring your 0 back in. I've got 0 0.010, 0 0.020. I hope you're following what I'm doing there with that. 0 0.030, all the way up. The biggest one on our table, I forgot a 0. The biggest one on our table is 6, 7. So I want to go probably up till I have 7. Sorry, I'm actually making a mistake with my zeros. Just make sure you got it right. So 0.040, 0.050, 0.060, and 0.070. And that, if you like, is like our 70, and this is our 67, and that's going to cover everything we need. You can keep labeling if you want, but we're not going to need anything bigger than that because our data set doesn't have that. Okay. So I'm going to leave that up here out of the way, and you can kind of keep an eye on how I'm doing. My very first one, I'm going to go 360, and then I'm going to have 0.067. Now, if you're feeling a lot more comfortable with graphs, you might just be able to kind of, oh, there's 360, there's that one, and plot it away, and happy days, good for you. But I'm going to really pick it out and show you how I do it, and do it as clear as I can with my ruler and all the rest, to make sure that I'm being accurate and to make sure that you know what I'm doing. Okay, so 360 kilopascals, I have 350 here, I have 400 here. Every one of these boxes is like an extra 5, so that would be 355, 360, 70, 80, 90, 400. Okay, that might be hard to see. So because it's 50, it's going from 0 to 50 in every box. Each one is 5. Each small box is 5. So I'll show you down here. It might be easier to see. So if I start at 0 and I have every small box, it could be difficult to see on the camera, but have a look at your own graph paper and see if you can do this too. I'm going to have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So 25 is the middle of the big box, but just every little box is 5. Every big box is 50, so every little box is 5, because there are 10 little boxes in a big box. So if I'm up here at 350, I need to get to 360. So I go 355, 360. Okay, so I know I'm going to be here, and you can put a mark on your axis if that helps you. That's no problem. You're not going to lose any points for that. And I'm going to come across here, and you're going to have to figure out, how do I know where to stop? So you go here down to your other axis, you've got 0.060, and this one's easier actually because every one is just 1. So every small box will be like 0.061, 62, 63, 64, 65, 66, 67. So I just come out 7 small boxes. I'll put a mark here too, make it a bit clearer for you. Okay, and you can tell because I'm nearly at 0.070. Okay, and essentially you are going to be bringing these points till they meet each other. So I'm going to use my ruler and put it along here. You don't necessarily have to use your ruler. I guess I've been doing it for a long time and I don't use my ruler every time because I don't need to anymore. And you'll be putting a point here. Now, you could really go for it and use 2, but I know that up from my big box, I need to go up 2 to get to 360, and I'll just put a dot. Okay. Now, if you're comfortable with graphs, you might say this is a very long-winded way of doing it, but that's kind of what we're doing anyway. It's just to show somebody how it works. Okay, I'm going to have to cover my dot for a second so I can see my data points. Okay, all right, so I'm just going to pause here for a second and say that's how you get your first plot point. That's your first point on your graph. Make sure that you can do that. And then the rest of them are fine. The rest of them are just repeating the same step over and over again. Okay, so if we've gotten to here and you're feeling stuck, send in a question or go back over it. If you're here and you're like, I kind of get it, by the time we get to the end of the graph, you should be feeling more confident. If you're here and you're like, I know this is how it works, this is so easy for me, brilliant, then you can just skip ahead to the end and see how the graph looks compared to you, or go off to the sample answer and just have a look at that graph and make sure that yours is doing the similar thing. Okay, you should know anyway if you're getting a straight line through the origin, if you're on the right track. Okay, so I'm going to go a little faster through the next ones because it's the same thing again. Next data point, my pressure is 227 and my inverse length is 0.05. So I'll start with 227. I have already, sorry, I have a 250 and I have a 200. So I know I'm going to be somewhere in here. I know every box is 5. and you're going, oh, 7 is not divisible by 5, the 227. So we're going to just be going for the next nearest thing, which is probably like 225. Okay, so 200, 5, 10, 15, 20, 25. So this one here is 225 pascals. The next one would be 230 pascals. So if you like, you could kind of eyeball somewhere halfway through. You're not going to get super accurate on a piece of graph paper. If you were doing this on a computer, you'd be putting in the exact numbers and it would be very flexible. But it's kind of, you're going to be in between these two, if you can see where I have here. All right. I'm going to leave those marks there and we're going to find our L. This one's easy as anything because it's a nice and even one. It's 0.050. It's one of our main big box lines. So I'm going to come straight up here. Again, you could add your ruler to here if you wanted, because my graph paper has nice deep big box lines. I'm going to just rely on that. You could use your ruler to help you on this side either, and you know you're kind of in between these two boxes, so you can just put a point in between. Okay, I'm kind of going in between. The point of my pencil is big enough that it's not really relevant to where I am on it, if that makes sense. I can't get that level of accuracy by using paper and pencil. Okay, next data point, pressure is 214. So I'll come back over here back to my 200 and I'll go 205, 210, 215. That's realistically the closest I can get to 214 on a piece of paper. My length is lovely and easy, or my 1 over length is 1 over lovely and easy again. It's 0.040. That's one of my main big box lines. So I can bring it up. Now you can do like I just kind of intuitively there and track it up with your pencil like this. Okay, and you're coming up to here where you know you've got a point as close as you can be, the 215, 214 point. Okay. Something's looking a bit weird, but keep plowing through. We'll talk about that in a second. We have a pressure of 178. So we're going to look in around 150, 200 area. Halfway would be 175, and the next one will be 180. So that's a good spot to go for, somewhere in here. Okay. And my 1 over length for that point is 0.033. So I have 0.03. These ones are, we made it really easy on ourselves. So I just go 0.030, 31, 32, 33. Okay, that's okay to put the notches on your graph paper. Now you could follow that up really carefully and just make sure you're staying on graph number 3 or line number 3 and put a point here. Okay, if you're not that confident with following up the line like I just did there, especially if it's not a main line, use your ruler. Put it up there, make sure you're going straight and know that you're coming across from here then. Makes it a bit easier. It takes a little bit of a chance of error out of it, all right? Okay, we're flying through, 2 points left to do. We've got a 154 pressure. So we're looking around 150, and the next one up will be 155. I'd be happy to take that as about as good as you could get. And our next 1 over L is 0.029. So I'm going to say that at 130, I'm going to go back one. You could obviously go from 0.20 or 0.020 and hop up 9, but I'm just going to go 29 is pretty near 30. Move myself up here. I'm only 1 away from the main line, so it's easy enough to keep track of, and I'm there at the 154 point. Okay, so I'm just trying to get my coordinates to match. Last one is pressure of 136. I know that between 100 and 150, I've got 125, 130, 135. I'm going to take that as my nearest point, and my 1 over L is 0.025. So in between 0.020 and 0.030, right in the middle, I'll have like, if you like, 25, my 0.025. And I'll bring that right up until I meet the place where I have 136, which is here, and I'll do a point. Okay, points plotted. Not looking too bad. Heavy work done out of the graphing. We know this is Boyle's law, and we know that we're looking for a straight line through the origin. So we're going to grab a ruler and see, can we just do that? I'm spotting straight away, we're getting lovely, if you see along my ruler here, there's a lovely straight line pattern. And if I was to extend it out, say, oh yeah, our first point is really falling in there too. This one is way out. So you will have, and I know that's not very technical, you'll have sometimes where they're a little bit scattered, but you know, you put your ruler there and generally none of them are more than a couple of boxes away, and you're getting a pattern, you're getting a trend. This one's way out. I'm going to put a circle on it because I don't like the look of it at all, okay? something's funny going on there. So because it's so far out, I'm not for a second going to try to, you know, put a ruler sort of, you know, if I had a few scattered, one sort of guidance I would give is, you know, have, if it's not, so this is a beautiful one if you exclude that one, okay? It's really, really neat. Sometimes you get where you might have one or two up here, one or two down there. And I would say try to have as many above your ruler as you do below the ruler, and that's as good at as fit as you can get. Sometimes, you know, experiments aren't always that perfect, but this one's so out, I'm going to ignore it. There's something wrong. I misread my gauge, or I misread my meter stick, or I did a calculation wrong along the way. This one I'm going to ignore. I'm not going to include it when I fit my line. So when I draw my line between my points, I'm not including this one. Okay. And we'll come back to that when we are in the question. Just for the purpose of the graph, that's what's happening, and that'll come back. When you look at question 2, the full video, you'll see a bit of an explanation around that one, okay? So through the origin, straight line, keep your pencil line, go up past that last point. It's not join the dots, you're not just joining dot to dot to dot. What you want is a general trend or a fit. That line is its own thing, okay? It's not just a way of joining the dots. I came in through the origin, so my line is going through, origin is 0, 0, the point where the x and y axis meet, and I came out again past my last line. Okay, so I'm done. I've drawn my graph. It looks good. I can go back to my question, and I'm kind of hoping that I'm going to be saying my line of a straight line through the origin shows proportionality or something like that. So that's it for the graph. We'll go back now and have a look at the rest of that question 2 for higher level question 2 of the year 2022. And if you're just here to practice graphs, great. I should have a few more there. There's never any shortage of graphing questions for you. Graphs, they don't, in a marking scheme, you won't see an example of a graph. You'll see a few things that they're looking for in your graph. So if you have questions about that, or you want to compare to a work you've done yourself, let me know and I can help out with that as well. Okay, we'll see you back at the whiteboard. So